I got it backwards.
Okay, so in this problem, I know this doesn't look like a truck. I just have wheel loads. But we're going to determine the maximum moment created here at B in the middle of this 200-foot span due to this traffic, this truck load. And the truck is moving from right to left, so it's moving in this direction. So the first thing I have to do is find the moment at B. So Mueller-Breslau says you do what? You go to that point, assume it has no moment, and I have a pin at C. Oh, that's a roller. Sorry. I'll just put the roller over here. It won't make any difference. But I did draw those backwards. Sorry about that. And then at B, I apply my positive moment. I think you can see that that point would move up and would make a pretty nice symmetric shape. So a more formal version of my moment at B would look like this. So I really only have one key value I need to find. What's the moment? Let me, I forgot to put my dimensions here. And also that this will also be in feet. So I just need to find this value. That's not too hard. So what I really have is a simple supported beam. I'll get the supports right this time. A roller at C and a pin at A. And now since I want this position, that's where my unit load is going to be. So I'll make a cut there, and you can look at either the left or right side to find the internal moment. I'll look at the right side. I don't think I need to do this, but what will be the reactions here at the pin and the roller? 1.5. It's going to be a half. That was an easy one. So I'll have my internal moment at B. I'll have that reaction over a distance of 100 feet. So if I sum moments at the cut equal to 0, you have a positive moment at the reaction, a negative moment created by 1/2 at a distance of 100 feet. So the moment at B is 50. So pretty quickly we have our moment. So now we have to work through all the cases. So let's start with, say, case 1. So since the vehicle is moving from right to left, I'm going to bring the vehicle midway to the forekip is right there at that position. So give me a second to redraw my influence line for the moment at B, and I'm going to bring that first load, the forekip load, right to the top, and then 10 feet back would be the 15 kip load, and then another 20 feet back would be the next 15 kip load. So I'm looking for values at these locations. So I know this one is 50. By the way, those units are in feet. So the slope of the line is a rise of 50 over 100, or basically 1/2. So if I move 10 feet, I drop 5, so this would be 45. I move another 10 feet, I should drop 10, which should be 35. That makes sense, everybody? So now the moment at E, I'll say 1 for case 1, would be 4 kips times 50 feet plus 15 kips times 45 feet plus 15 kips times 35 feet. You guys have to help me out with that. I can't do that in my head.
200. Oh, I'm going to have to use calculator.
I know this is 200. After that, I get kind of a little iffy. 1,400? Anybody else get that? So that should be kip feet. Anybody else get that? Yes? No? Maybe?
I did. Just did.
You did?
Yeah.
Okay. So now let's go to case 2. So I'll redraw my influence line for the moment at B. And in this case, I'm going to let the second load, 15, be at the maximum value. And then 20 feet back is the other 15 kip, and 10 feet forward is the front 4 kip load. So I'm looking for these values. Now I know the top is 50. 20 feet back would be a loss of 10, so this is 40. And this is 10 feet, so a loss of 5, so this is 45. So therefore, the moment at E, say for case 2, would be 4 kips times 45 feet plus 15 kips times 50 feet plus 15 kips times 40 feet. What's that equal to? I think it's going to be bigger than the first case.
1,530.
1,530. And that's kip feet. So that looks like the more critical of the two. Let's go ahead and check the third case. In that scenario, the last wheel goes to the maximum point. So there's our 15 kilonewtons from 15 kips, and then 20 feet in front, 15, 10 feet in front, 4. So I'll have to find these values. Again, we know the top is 50. So I go 20 feet, that's a drop of 4 to 40. Another drop, 10 feet is a drop of 5 to 35. I think this is going to be smaller, but let's check it anyway. So ME case 3 will be 4 kips times 35 feet plus 15 kips times 40 feet plus 15 kips times 50 feet. 1490?
Yes.
That's closer than I thought it was going to be. So then the maximum will be the largest of them, which looks like it's 1530 kip feet.
Does it have to be like exactly a week and not be like maybe 2?
That's not the maximum moment in the beam. That's the maximum moment at B. We haven't talked about how to find the maximum moment for a set of moving loads yet. Remember, we're using influence line. So what's the definition of the influence line, Mr. Bird?
The fluctuation or variation of movement across a single point.
At a specific point. In this case, B. Is B the maximum moment in the beam produced by this load?
Yeah.
No. It is not.
What it actually is it?
It is not. Maximum moment does not occur at the middle of the beam for a set of moving loads. What? What? We'll have to talk about that next. Any more questions about this?
Why are you asking us questions we're not going to know?